look at it now. My friend Igor from MyTechFun recently tested this, the iDryer. He showed you just how incredibly effective it is at drying filament, but that performance comes with a few quirks. In this video, he asked me to show you the full story, how to set it up, how to use its advanced features, and how this powerful little box managed to crash our entire Sovol SV08 MAX. So let's get it connected and find out what happened. Hey everyone, I'm Gergo, and this is Gergo Print 3D, the YouTube channel where my little nephew Levi and I share all the adventures we have with our 3D printers and DIY tools. Like all our videos, this one has chapters, multilingual subtitles, and translated audio tracks now, so check if your language is available. If you followed our adventures, you've seen us test a few filament dryers in the past, but the iDryer is different. It's an intelligent device that connects directly to your Klipper-based 3D printer. Normally, this is a DIY kit. The documentation recommends printing the parts out of heat-resistant materials like ABS and specifically suggests a carbon fiber variant, likely because it adds rigidity and makes printing large ABS parts easier. All the parts are cleverly designed to be printed without supports. The CAD files are available for this single spool variant and a wider two-spool dual model. For convenience, Igor received a pre-printed version and he was kind enough to pass his sample unit on to us. What makes this project even more interesting is its origin. To quote Ruslan, the developer, directly, yes, it's just a small personal project that goes against the odds, so to speak. The body is 3D printed with flexible TPU seals and has this playful, light Pac-Man design. Inside, the spool sits on smooth rollers. The filament exits through this clever rotatable PTFE coupler. You can orient it vertically or horizontally, and since it's open source, nothing stops you from redesigning it for other angles. The electronics bay holds a safe and powerful 100-watt PTC heater, a high-quality SHT30 sensor, and the main controller board with multiple layers of hardware safety. When we first got the unit, it came with no instructions, so I was a bit lost. My first instinct was to plug it into my Windows PC. Yeah, I know, I'm a Windows user, but of course nothing happened. That's because the iDryer isn't a typical peripheral. It's designed to be part of your printer. Ruslan quickly pointed me to the official documentation at docs.idryer.org. The setup involves adding a new MCU to your Klipper configuration. Now, here's where we make mistakes, so you don't have to. The documentation has two main branches, MCU and second MCU. My first instinct was to just download both directories and add both include lines to my printer CFG. Of course, Klipper threw a fit. It complained that an MCU was already defined. It took me a moment to realize that since our Sovol SV08 MAX already has a main MCU, we only need the files from the second MCU branch, and certainly not both. Let me walk you through the exact steps on our SV08 MAX. First, you will need to SSH into your printer. For Sovol printers, the username is Sovol and the password is the same, Sovol. Once you're in, find the active config directory. On Sovol printers, it's under printer data/config. See, we not only have printer CFG here, but some backup versions of it too. Here we need to run the installation script for the second MCU branch. Next, find the serial ID of the iDryer MCU with the command ls dev serial by ID *dot. Copy the full path for the new one. Now head over to the mainsail interface. Under the Machine tab, go into the iDryer second MCU directory and open the iDryer .cfg file and paste the serial ID you just copied into the serial colon line. The final step is to open your printer CFG and add this include line. Save and restart, and you're done. Since we just gave you the full step-by-step guide to get this working, saving you a bunch of time, please reward our efforts with a like below. Thank you if you did. After restarting Klipper, how you interact with the iDryer depends entirely on your printer's screen. On the stock touchscreen of the SV08 MAX, well, you won't see any of this new functionality. However, with an HDMI Klipper screen upgrade, the iDryer's temperatures will show up right in the temperature section, and all the macros will appear in the macro list. You can even rename these macros or hide unused ones for a cleaner interface using the standard Klipper screen UI. Interestingly, for printers like the regular SV08 or Sovol 0 with their mini screens and clicky wheels, it's actually much easier to add these new controls with just a few lines in the configuration. For printers with a non-standard touchscreen like our stock Max, your best bet is to find all the controls and the info on the mainsail web interface. In fact, this is exactly what I was using during our first tests with Levi.
Yellow, purple, green, red or orange, I don't know, blue, orange.
Okay. Now turn it around so the door at the back can be seen. And
there is no LED in the back.
no LED, but there is a little door on the back. And look at it now. Now it's closed, right?
Yeah, I scared for a second.
And now?
It's half open.
And now it's fully open.
Yeah.
For testing or building your own macros, you can operate the servo manually from the console between 0 and 180 degrees using a command like set servo equals srv underscore u1, angle equals 90, for example. The iDryer comes with pre-configured macros like PLA U1 or PETG U1, but the real magic is that these are controlled by simple user-editable Klipper macros. For example, the default drying macro oscillates the heater temperature between your set value and 30 degrees higher to heat the air, while opening the little door at the back every 5 minutes for 10 seconds to vent moisture. But none of these values are carved in stone. You are completely free to adjust or rewrite these macros to fit your specific needs. As Ruslan explained, you're setting the target air temperature, and the Klipper magic works to maintain it precisely, a much more accurate way to dry filament. The main advantage is clear: precise, high temperature drying integrated into your Klipper workflow with features like a long-term storage mode. However, there are side effects which you have to keep in mind. If the iDryer has a problem, like a thermal runaway error, it crashes your entire Klipper host. We discovered this together with Igor in a rather dramatic fashion. As we took the test sponge out during his measurements, we left the top of the unit open. This must have resulted in the effects of a thermal runaway, because the next thing we saw was my SV08 MAX had crashed. And this would be a major problem in the middle of a print when you're replacing spools, for example. It's something to keep in mind. Either use the off U1 command before opening the unit, with its serial number, of course, or make sure not to keep it open for too long. But here's a bit of inside information. Ruslan told me he's already working on a standalone firmware that won't be dependent on Klipper, which would solve this potential point of failure completely and make setup even easier. I also ran into a more subtle issue during a long PETG print, which really shows how different systems can interact in unexpected ways. About 4 hours into an 8-hour print, my SV08 MAX started pausing with a filament jam detected error. I could always resume the print, but a few layers later, the same error would pop up. The strange thing was, when I took the spool out of the iDryer and put it on the regular spool holder, the print would finish for another 4 hours without a single issue. It happened a couple of times. I printed large components for my venting manifold, and the errors always started to come around the 4-hour mark. And then it clicked. The iDryer's default PETG cycle is exactly 4 hours long. My theory is that while the iDryer was running, the heat slightly softened the PETG, making it easier for the auxiliary feeder to push through the long filament path here. As soon as the drying stopped and the filament cooled, the extra friction was just enough to trigger the MAX's sensitive clock sensor. The key takeaway is that the feeder of the MAX seems to be working right at the edge of its capability, and keeping the filament consistently warm and easy to feed is critical during these long prints. In hindsight, instead of taking the spool out, I should have just restarted the drying cycle or set its length to match the print time. So what are my first impressions? Pros: excellent Klipper integration and automation, achieves very high temperatures for a wide range of materials, incredibly effective and precise drying with smart air temperature and even humidity control, brilliant features like storage mode and a modular expandable design, and as Igor asked me to mention, it is incredibly quiet compared to the many dryers he has worked with over the years. There are cons too. The initial setup might be intimidating for Klipper beginners, but hopefully this video now helps with that. A dryer failure crashing your printer is a significant drawback, and of course it's currently limited to Klipper users only. Despite these minor quirks, which are all easy to mitigate, the iDryer is a uniquely powerful tool for serious 3D printing enthusiasts. It works well with our new SV08 MAX or any Sovol or SSH accessible Klipper printer for that matter. It's especially useful for an enclosed printer used for printing sensitive filaments, or in our case, even for multi-day PLA or PTG prints on the MAX, which did not fit into our humidity controlled printer room. It just makes sense to prevent PLA degradation or PETG bubbles from ruining a long print, especially on humid, rainy days. It's available for pre-order, and the whole project is open source. You'll find all the relevant links in the description below. Our goal was to release our videos together with Igor to give you the complete picture. He showed you the raw performance, and I hope we've given you a clear guide to help you with the steps to set it up with a Sovol printer specifically, but with any Klipper printer. And speaking of the SV08 MAX, the iDryer is just the next in a long line of upgrades we have planned for this massive printer. If you haven't seen our first videos of the series, be sure to catch up. And for those who have been following, I'm thrilled to announce that the acrylic panels for my top riser design have finally cleared customs. So I am finalizing the 3D printed parts, and we are building that very soon in a video. I've also got 3 meters of white LED strips to properly light up the huge build chamber, which gets very dark with the enclosure on. And to prepare it for printing high temperature material and also to make it quieter, we'll be adding sound dampening and heat insulating foam tape to all the enclosure panels. So if you're a new Max owner, be sure to subscribe, because all these practical mods are coming in one of our next videos. If you haven't seen Igor's video yet, where he tests the iDryer's amazing performance, you can watch it right here. And for more of our adventures with the printer we connected it to, check out our SV08 MAX playlist over here. With your filament now perfectly dry, there's only one thing left to do: go print 3D. Thank you for watching another Gergo Print 3D video all the way to the end. Happy drying!